Hello and welcome to the channel. We've got a Laney LC15R. This amp is in because it is blowing fuses, so we're going to have a look and run it up on the current limiter and we'll see what we get. So we'll just have a quick look before we run it up. The knobs have been changed. We've got inputs, we've got a gain, bright switch, bass, middle, treble, volume and reverb. Pretty simple thing. We just turn it around and look at the back. We've got a Celestion 1030 in there, and that's not the original speaker, I don't think. Could be wrong, but I don't think it is. And then we've got external speaker, got a line out, reverb foot switch and a send and return. So these are not bad amps actually. The PC board extravaganza, and sadly the tube sockets are into the PC board, but they're actually not bad amps. So we had one of these on the channel about 18 months ago and it sounded pretty splendiferous on the 4x12. Put this amp on the current limiter and we're just going to bring it up steady and switch on and see what happens. Well, the bulb's lit, but I've only got 48 volts, 50 volts, so I'm just looking at on the wall outlet meter that I've got there. That's going up now. I've only got 54 volts on it. I've only got a 15 watt bulb in it. So that's climbed up to about 70 odd volts now up there. So I'll stick another 15 in. We've got 30 watts. There we go. Now you can see the pilot lights come on, and we've got about 140 volts going into it and climbing. And we've got sound. So yeah. So we've got 30 watts of current limiting, and we've already got sound on there. So bulbs are dim, they're dimish. So we're just going to keep it on that 30 watts of current limiting to start off with, and we're going to now, let's have a look at in the back. Oh, we've got some very microphonic tubes. I've got it turned up flat out. Word. Now I have noticed this amp's got JJ tubes in it, and some of these Laney amps have quite a high plate voltage and the JJs don't like that very much. So we've got 188 volts going into this amp now from the wall. Now we've got 80 watts of current limiting, and the voltage has gone over 200, 210. Still nothing. Let's take 40 out, put 100 in, so now I've got 140. That's taken us to 226 volts now going into this amp. Transformer's cold, power transformer. Right, let's take the other 40 out, put 100 in. 200 watts of current limiting, that's giving me 230 volts. So what I'm looking for now on this meter is the current going up. And it isn't, and the bulbs are barely lit. Well, in fact you can't even see that they're lit. So let's just lift it off the current limiter. Strange, current's not going up. So the symptom, just had a read, the symptom is the fuse on the board, on the main board, occasionally blows, so that will be the HT fuse, I'm guessing. The AC power going in fuse is there, so ooh. And here we go again. We've got it out the case, and already we can see that someone's been in here. So let's just have a look what we've got. So it says here, new transformers fitted in 2023. Now I'm looking at some of this wiring. So here I've just got a wire connected to nothing. No idea what that is. Although I have... And where's that coming from? That's coming off the main board. So I've got a wire here doing nothing. So if that's got voltage on it, and it is exposed, well, only slightly, so that's something we need to check. This wire's been botched on here, trace has been pulled back, and I'm just looking at the pins on that. So these are EL84s, 1, 2, 3, 4 filament, and then I've got another one. That wire is linked then round to here, it's been put on. So there, down there, there to there. So that trace must be broken then, because that follows along there, goes down there, follows along there, and then goes back up to that pin there. So that wire's been botched on because that trace is broken. So no telling what's been done to that. So that's been botched up. Oh, the dreaded electrical tape. My days, look at this. Oh dear. That. And that is coming from one of the transformers. Where's that going? That's going to ground. That's going to the speaker socket. So that's on the secondaries then. Look at this here. Bird poo extravaganza. So they're going from the secondaries. So where is that one going? That one's going. I'm not sure where that one's going. My word. So these are the secondaries then on the output transformer. That is the extension speaker socket. That wire then goes through there, connects somewhere onto that board. Dear oh dear. We've got a wire here, that's shrink tube, fair enough. Fuse here, I've got strands of wire coming off of there, that needs redoing. Whew. There's some bad work in there, my word. Right, I've got the macro lens on now, so let's just have a look at these wires. Can you see there? Look at that, that's all strands there, and it's not soldered on, it's cold wires there. Look at this one again, this one's even worse, and this amp's blowing fuses. Is there any wonder with this going on? This one here is, if we look, you see the yellow one, just get that out of the way there, get the light on that, see the yellow one there, poorly soldered. And then this wire here is what I presume must be this one, which is floating around in here. So although I certainly ain't going to connect it up and try it. So is that off the centre tap? Is half of the AC missing off there, I wonder? But that's broken off, so that's not been soldered on properly. None of those have. Ah, that's so dangerous, really dangerous. Got strands of wire here. This wire added on there we've seen. Anything else? So some very, very bad soldering work been done in this amp, and there's no surprise that this is blowing fuses. So what are these two coming out the transformer here? They're filaments. Right, let's have a look. You're looking round, so there's the fuse holder, you can see. And there you can see the wires that have been botched up on the secondary with the dreaded electrical tape. So if we just move into here, you can see the wire there that's been added on because that trace has been damaged. And it's been soldered onto there. Some terrible cold solders here. If we look, sorry. If we look here, you can see their cold solder, badly soldered up. That one's a bit of a cold solder there, that one's very cold though. Looks like a dry joint there maybe. Solder on the board. What is this wire? That's a ground. Again, strands. And if we look, and you probably, I don't know whether we can get in under there. Let's just see if we can go in sideways and get in. So if you look there, can you see that one there? That's cold as well. This amp is in a bad state. Yeah. There's cold solder, just bad. They've just used cheap and nasty solder. Look at that one there. There, my days. That is pin 2. Actually, no, that's a 12AX7. Sorry, but it's still pin 2. But that's a grid. So there's a lot of work to put right in this amp. All this solder wants sucking off of these. And you can tell just by looking at this solder. It's ball bearing looking. They're like ball bearings. That's because they've probably used some cheap Chinese solder on it. And you can see it all round. They've obviously touched all this board up with it. Yes. So this amp is not in great shape. These have been changed here, and they're just, look at that one. It's not even seated flat onto the board, you know. So no glue on those. No big job to sort that out though, is it? Check out the ground there. We look. See that? That's the Bird Poo Extravaganza. That's just been, I suppose it's just okay, but it's not brilliant, is it? And it's riveted as well. So that's just the fault of the amp design, though, I think, anyway. So that riveted ground, but riveted with a star washer. Odd. So I don't know. Has that been? That doesn't look factory, does it? So has somebody just riveted that ground in? That's a no-no. A real no-no. Got this ground connection that's been made. I'm sure that's not factory either. That would have been better on the chassis, not on the back, because that can be loosened off. You know, somebody's thinking they're taking this to bits, don't know what they're doing, and they loosen that off, then they've loosened the ground off. So that really, to be fair, should be, I mean, it's not bad, but this hole's here, you can see. So I mean, easy for me, I would have grounded that somewhere, you know, or even here there's some holes, although there's tie wraps through those, but I would have grounded that somewhere else rather than there. So what is to do? Well, the first thing is to find, we assume that wire goes there, but assuming is not, I mean, it's the only place it could go, I suppose, but assuming is not good enough. So we need to test, and we need to see where that wire goes. This is high voltage, so we're not just going to stick that on there. Now the customer's saying the fuses are blowing on the board. I could only see 2 fuses there, and it says T5 amp, and they are filament fuses on there. So I don't see any other fuses in this. So the fault could be the filaments that's causing this problem as well. And given how this board's, we've got these wires botched on there, so this is going to want a real coat of looking at. This amp, a real coat of looking at. There is a lot of work on this amp to make it safe. Now, my point of view on this is, I've opened this up now. This has become mine. So it's up to me to put all this weight right. I can't button this up and just leave this amp like this. It's not safe. And you know, although we've got shrink tubing on these, but you're kind of looking at this, and is that another join in that? And you're looking at these and you're thinking, you know, are these actually soldered inside? I think they are. Or have they just been, you know, put together? Same with these. At the moment, I've not quite worked out what's going on here. Let's we need to just put something over that wire for a minute while we're testing. Where you know that noise? That's the dog dreaming. I'm just going to pop that over there so that while we're testing we don't knock that wire onto the chassis. So I've got this meter set on AC, so my assumption is that they are the AC feeds on there, and I am correct, they are. We have 425 volts. That's a lot of AC there, that is coming in there. So you can see the meter there. So that's the red wire you can see, and that's where the red wire should be. I've got no. So got no voltage on that at all. So that's, at least there's no voltage on it. So we need to find out where that's connected. I suspect that's connected on one side of the rectifier. Let's just see what else we've got here. So let's go on to AC again. So we've got this orange and yellow wire bound together, and we've got a yellow wire here. That's got 34 volts AC, so that could be for the bias because it's fixed bias. And is this the center tap then of something? 17, so that's the center tap. So they'll be the bias then, windings. So let's just see what we've got on let's go on to DC then, and let's just see if I can stand this up so you can see it. Let's just see what we've got on the plate. So we've got 987, 255 on that plate. Bear in mind, I've got this current. There's only 188 volts going into this amp, so I've got it on the current limiter, and I've got 425 volts AC. Let's try on this side, 987. Sorry, wrong one. 987. Yep. Screens 9. Yep, we've got screen 251 on the screen. 253, that tallies up. Screen on this side. So lemon there. No screen voltage. No. Screen 251. Screen. No screen voltage on that tube. So is that tube blown? Finally. Man, there'd still be voltage there, wouldn't there? Duh. So we're missing screen voltage on one of the output tubes. That again gives me an idea of why there is low current being drawn off the wall. I'm just going to let Pink in. Come on, Pink. You're on the prowl tonight, aren't you, missus? Hey. You're not allowed on the bench, we've got high voltage, you know that. So you won't be putting in an appearance. Right, enough digressing. So no screen voltage there. Plate voltage, no screen voltage. So there's a problem. Pin 9. Yep. Ah, so we've got voltage there, look. Just shift my hand, duh. We've got voltage there, but we haven't got voltage on the pin, so they've damaged that trace. There. So that trace is damaged with the poor soldering there. Dear. Oh dear. This amp is in a right state. So I don't know who fitted those, but Billy Bodger strikes again. Or someone actually read one of the comments. I've not had a chance to reply yet on I think it was a Brunetti amp. Barney Bodger. This is how Billy Bodger's brother. Barney Bodger. I think Barney and Billy's been in this one. Oh dearie me, dearie me. And I thought I'd do a quick assessment video on this, and I thought, you know, I thought this would be just a quick fix, you know, just want a set of tubes in it, and I thought I'll open it up, just check if it's a tube that's blowing the fuse. I'll just order a set of tubes, and then I can get on with other things while I'm waiting. Drop them in, bias it, and it's gone. But this is a minefield, a real minefield. So only one of those tubes is running. And I can see the trace where it's broken now. I bet you spotted that on the macro camera, didn't you, when we was looking earlier? Because on the macro lens, because obviously I've only got a small window on this camera looking through, and I would have found that eventually when I started wading through this lot. So that trace is damaged. What else is damaged? So pins 4 has been bridged. Pins 4, pins 5. So that will be the AC volts. Let's just see what if we've got what sort of, and we have got it on the current limiter, so we're not going to get the full voltage. But let's just see 1.8 odd there. That seems a bit low to be, even with what we've got on the current limiter. That does seem a bit low. 1.8. Oh, 4.7. Nah, it's more like it. Just didn't get that quite on there. Yeah, 4.7, 4.8, near enough. That seems to tally up really, because we've only got 187 volts on the wall outlet coming into the amp. Let's go down the line, see what else. So let's have a look. That's a plate. Am I right? Is that an 8? Oh, it's on AC. Duh. 180 volts. That tallies. Cathode. Filament. Pin 6 on that bird poo. 181. That's good. Let's try pin 1. 214 on there. 2, 3, 4, 5, pin 6. Yep, 132. 214. 132. Let's check the schematic on that. This tube, pin 1. 174. Pin 6. 151. So all the plate voltage is there on the tubes. That's all there. So we're missing just screen voltage off that one EL84. So this amp's been running very sick. If that's the other half of the AC coming off the transformer, it's missing half of the AC if that's the case, and it's got no screen voltage on this tube either. Right. So do you think it can get any worse? Yes, it can. Much worse. So I'm scanning down under the board looking for where this wire goes, and I can't see where it goes. But what I can see is 2 large radio capacitors lay on the side, just lay on the board. And obviously this chassis is too shallow for radio capacitors, which is obviously why it's got axials in. Somebody's done that on the cheap. It just goes on, and I just keep finding things wrong with this amp. Let's just have a bit of a summary then of what's actually wrong with this amp. So it's had this transformer fitted, and it's been badly fitted. We've got wires virtually hanging off there. We've got one wire floating in the breeze, which we think's come off that transformer, but we're not prepared to connect it up because it's high voltage till we know. Never assume with high voltage. If you've not figured out the wiring, don't connect it. So we've got all of that. Then we've got this botched up filament wire here because they've damaged the trace on the board. We've got no screen voltage on this tube. We've got the insulation tape extravaganza here with all this botched wiring. We've got bad wiring on the fuse. We've got a couple of capacitors here, but that's only minor really. That won't be a big job to sort those out. And then we've got the bird poo soldering cold joints all over this board where they soldered, used crappy solder. It's just a mess, and that's what I can see. And the only other thing is this ground here. I would prefer that to be on the inside of the chassis, not there. There's one thing putting that there if it's unavoidable, but on this amp, you know, that could have easily been put. There's even holes on here you could have put that into. And by the look of it, the only fuses that could be blowing on this board, which I don't think there is any HT fuses in these amps. There's something in the back of my mind says there isn't. But the only two fuses you can reach are these two filament ones where they've done this crappy wiring there. So that tells me that the occasional fuse blowing is the filaments going. So there we go. So I need to now get with the customer and find out a bit more about this amp, where it's been, who's fitted these transformers, blah blah, because this is a real mess and it's going to take a lot of sorting out. A lot. Personally now, how this, and I don't know if there's other techs watching this how you'd feel, but personally now I'm prepared to slam this amp is dangerous sticker on this. I must not be plugged in. You know, this alone floating around in there, things not connected up properly that could fall off and short. This amp's not safe in my opinion. Let me know what you think in the comments, but in my opinion this amp's not safe. So this was going to be a quick open up, and I think I'm kind of thinking it'll probably just be a tube that's blowing the fuse. It's turned out not to be, and I thought I could order some tubes up, get the tubes delivered, put the tubes in, quick buyers, this amp would be done and we could have a good old blast through it and it would make us a good video. But unfortunately there's no blasting on this, and I'm afraid that's going to have to do it for this one. So this is now going to be in two parts, or this is going to be the only part, because this amp really, you've got to question whether it's, you know, an economical repair. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next video. Bye bye for now.